will be. So, what did we watch? I went to leave about
5th, which personally is my 34th year. I should probably do this to sleep, shouldn't I, really?
well, we will.
It wasn't just those 10,000 astrometric... I'll find a piece of paper in a minute. Here it is. It wasn't just the 10,000 astrometric measures, it was the fact that there was also... Meantime, I'll get back to the computer.
Okay, TA, as you may be aware, started back in May 1964 as a casual astronomer.
Telescope observations as well. So the whole lot are being moulded together into one basically enormous data set. These are not. It's available around the world, literally worldwide, for the object or the area you're interested in. Professional astronomers don't understand colour images, so there's no official format for coloured FITS files.
Have a show of hands and they all went for the eyepiece, and I'm sure today it will be the CCD camera. Anyway, things are slightly changed. Anyway, what the top?
Right hand side. Forward.
And it's the term that's stuck universally through the world, surveys of the sky. When I look at this...
Have a go at me for the title. The short life of 2008, TC3. Yes, I know the actual thing's billions of years old, but the designation 2008 TC3 was in astronomy at the moment is looking for near-Earth objects, primarily because they pose a threat to the Earth, and so it's a fairly well-funded activity. And flash from the bolide happening behind us. It could be a headlight, but I prefer to think of it not. Anyway, so one of the key things here is that we have an object that we've observed in space, which we know its orbit very accurate. Dawn, showing effectively the train of this object after it had been affected by high altitude winds, and let them fall under gravity with atmospheric drag. And so what you get is you get the small objects fall first along the track because they're much more affected by atmospheric drag, and larger objects fall later along the track. That asteroid is. And we also know accurately the orbit of 2008 TC3. You've got a 4.2 metre telescope taking a spectrum of an object that's at that time would have been, what was it, 17? 14. The first person to discover an asteroid who can actually hold a piece of that asteroid in his hand.
I'd like to explain to you, my work really wouldn't be possible without what amateurs do. I want to explain why it's not just a useful extra thing, that the amateur contribution to astronomy, it's not just a handy thing, nice to have, it's a really vital thing. And the strengths of amateur astronomers really complement those of professionals in understanding, in particular, certain types of objects. And it worked from the start and didn't have all sorts of problems that brought it to everyone's attention. But Spitzer has actually been a pretty incredible boon for astronomy. And then you can see right through those dust clouds into what's going on beyond. As long as the dust, just like the light echoes around supernovae, you see a spectacular light echo developing here as the flash from this nova explosion lights up distant parts of the nebula that weren't lit up before. One of them is in front of the nova and the other one is behind. And in this way, by looking at that kind of pattern, you can tell what is where in this nova explosion. And the shell of gas that it previously threw off in the last 10-15 years is that most of them are actually amazingly non-spherical. Back in the days of the early Ross and the early observers and people like Herschel, who was